only when the aircraft distance measuring equipment, or DME, enables a pilot to establish the distance of his aircraft from a beacon. The complete DME system comprises a ground station, often co-located with a VOR beacon, and an onboard receiver and data display. As well as giving the distance from the beacon, the DME display may also show an aircraft's ground speed and the time required to arrive overhead the beacon. The ground speed shown is meaningful only when the aircraft is tracking directly to or from a station. The time required readout is meaningful only if the aircraft is tracking directly to the station. By obtaining magnetic bearings from a VOR beacon and range readings from a co-located DME, the pilot receives an accurate fix giving him his exact position. The picture on the screen shows an aircraft approaching the Daventry VOR DME ground station on the 180-degree radial. The pilot can read from his DME indicator that the distance of his aircraft from the ground station is 30 nautical miles, that the aircraft's ground speed is 120 knots, and that the time required to reach the station is 15 minutes. If the onboard DME equipment has no ground speed readout, an aircraft's ground speed can nevertheless be easily calculated when flying directly to or from a VOR DME ground station. The pilot simply times the interval between two DME range readings and carries out a mental calculation. For instance, if in a time interval of 1 minute the aircraft has travelled 1.5 nautical miles directly towards a beacon, the ground speed of the aircraft will be 60 times 1.5, giving 90 nautical miles per hour, that is, 90 knots. As signals from a DME ground station are propagated in all directions, the DME position line is circular as shown here. En route, therefore, a pilot can obtain an accurate position fix by ascertaining the distance of his aircraft relative to two separate DME stations. DME operating frequencies fall within the UHF range of 962 to 1213 MHz. These UHF frequencies, however, are not directly selectable. Your DME control unit will have an associated VHF frequency selector. DME frequencies are most commonly paired with VOR frequencies. So when you select a VOR frequency on your VHF nav box, you automatically select the frequency of any co-located DME station. DME is also paired with localizer frequencies of instrument landing systems. DME measures the slant distance of an aircraft from the ground station. It is therefore a line of sight facility. Though the slant distance from a beacon is slightly greater than the horizontal distance, in practice, the two distances are near enough to each other for the difference to be negligible for the purposes of aircraft navigation. For instance, an aircraft at 3,000 feet at a distance of 15 nautical miles from a DME ground station would be at a height making an angle of only 2 degrees with the ground at the DME beacon. At this angle, the difference between the horizontal distance and the slant distance of the aircraft from the beacon would be only 1/100th of a nautical mile. Obviously, such a small difference can be ignored. When the aircraft is overhead the ground station, the horizontal distance will, of course, be 0, while the DME indicator in the cockpit will still indicate 3,000 feet, or about half a nautical mile. This is the position of greatest error, but as you will appreciate, half a nautical mile is also a negligible value. If the DME station is at the airfield of destination, visual contact will have been made long before half a nautical mile to run. If you are using the station as an en route overhead fix, knowing your altitude will be enough for you to calculate the overhead reading. DME works on the secondary radar principle. This is explained in a separate lesson. Here it is sufficient to say that the DME ground station is fitted with a type of transponder that responds to interrogation signals from aircraft tuned to the correct frequency. An aircraft sends out an interrogating pulse, and the ground station transponder responds by retransmitting a strong answering signal which is received in the aircraft. The DME equipment on board the aircraft converts this signal, using simple distance, speed and time formulae, into a digital readout of distance in nautical miles. DME transmissions obey the line of sight rule. Thus, the higher the aircraft and the ground beacon, the greater the theoretical reception range. The formula for calculating the maximum line of sight range is shown here. Intervening high ground means that in order to receive DME readings, the aircraft will have to be at a higher altitude than that suggested by the maximum range formula. Range errors may also be caused by co-channel interference from two or more ground beacons having the same frequency. A designated operating area is published for all DME stations in which co-channel interference is unlikely to be experienced. Further information on DME ground stations in the UK can be found in the appropriate section of the UK AIP. DME is very accurate. The total system error for DME should be no more than plus or minus 0.2 of a nautical mile for recently manufactured aircraft. For older aircraft registered before the 1st of January 1989, the error is 0.25 of a nautical mile plus 1.25% of the range. Slant error is only of any significance when the aircraft range is less than 3 times its height above the beacon.